15.2, a familiar shape. A function defined by the radical of the independent variable is known as a root function, usually expressed as f of x equals the square root of x. Use the table below to help you apply your point. Sorry, I made a typo. Okay. Well, one thing you should probably know, just by looking at this, there are already a few inputs on here that it's not going to be possible for us to get an output for. All right. So those would be -2 and -1. Because we just showed in the do now, you can't put a negative number in a radical. You'll get no real solutions. So here we have no real solution. And here we have no real solution. All right. That's because if x is in this radical, x must be greater than or equal to 0. That's going to be our domain. Any value of x less than 0 is going to be negative, so there's no way I can plug it in to this equation. It won't give me a real answer, right? Try it on your calculator. Make sure we can see that. Good. Actually, let me make it a little brighter. Oh, it's too dark. That looks better. All right. So we cannot put in -2, right? It says non-real answer on the calculator. All right. However, I do know the square root of 0, right? The square root 0. What times itself equals 0? Well, 0 times 0 equals 0, so we can just write this more simply as 0. So at that point, I can plot 0, 0. All right. Next, we've got 1. So what times itself is going to equal 1? Well, 1 times 1 is equal to 1, or the square root of 1 is 1. So that's another point I can plot. All right, radical 2. Now this, I have a feeling, is going to be irrational. Because 2 is not a square root. 2 is not a perfect square, right? All right, so we're going to get a number that's going to be sort of tricky to graph. 1.414. And I don't really need to get that far down because, I mean, I can only be as accurate as I'm approximating here. So I'm going to go to 2 on the x-axis, and that's 1, and then 1.4 will be right about there. But I'm going to add a couple more rows here as well. And I'm going to add some numbers that I think would be much more valuable inputs. And those numbers I'm thinking of are perfect squares. So what's the next perfect square after 1? All right, and that would be 4. All right, we know 2 times 2 is equal to 4, so radical 4. Why do I keep making that radical so off? Radical 4 is equal to 2. So I go to 4 on the x-axis, I go up to 2 on my y. We can also say that 2 squared is equal to 4. All right, 1 squared is equal to 1, 0 squared is equal to 0. Whatever this entire number is squared will be equal to 2. I can't write it all out because it's irrational, but it will be equal to 2. All right, the next perfect square after 4 is 9. All right, and 3 times 3 is equal to 9, so radical 9 equals 3. So I'm going to go all the way to 9 on this x-axis and then go up to 3. All right. Okay. So this does look slightly familiar to a function that we've dealt with a lot in this class. And maybe it would help if you tilted your paper this way to look at it. What function does that remind you of? And hopefully what you're saying is that it reminds you of a quadratic function. Or at least half a one. Right? Instead of squaring the input to get the output, we're squaring the output to get the input. And because we're doing that, because we can't square a number to get a negative number, we will never have any negative outputs for this function. another reason why, if you think about it, we could never call this a function if we had negative outputs. Right? If I were to try and make the mirror image of this by putting my points, you know, here and here, let's just, you know, just entertain that thought. Because technically, -1 times -1 is 1. But if we look here, what does this pass the vertical line test? No, it's hitting the function twice. So that would certainly not be considered a function. And anyways, we can't even possibly have, we wouldn't, yeah, you can't put a negative, you can't get a negative number out of a principal root. If we made this a little bit different, if I said f of x is equal to plus or minus x, then I guess you could draw it like that, but then it wouldn't be a function. So we only define root functions as the positive root, because otherwise it wouldn't pass the vertical line test.